Hello and good day everyone. Welcome back to my YouTube channel. This is Sir Marcy and we are still on our second part of our lesson, Product Rule for Radicals. If you're new to my channel, please consider subscribing so you'll be notified with my latest videos. Alright, let's try to recall first our lesson. Let's say we're going to simplify each radical expression. For number 1, if we're going to simplify square root of 12, first is we will apply prime factorization. So you can use other factors, let's say as long as the product is 12. So here I'm going to use 4 times 3. And we know that 4 has a factor of 2 times 2. So since the index is 2, we're going to group them by 2. So meaning to say, if we will rewrite this, that is simply 2 raised to 2 multiplied to 3. After that, we apply the product rule for radicals. So that is square root of 2 squared multiplied to square root of 3. If you still remember the property we have, the nth root of a raised to n is simply a. So here, since the index and the power are the same, so that's cancelled out, the answer now is simply okay, 2 is square root of 3. So the simplified form of square root of 12 is 2 is square root of 3. For number 2, we'll do the same. First is we apply factorization. You can use other factors aside from the one that I'm using here. Let's say I'm going to use 9 multiplied to 2. Then 9, we have 3 times 3. Again, our index is 2, meaning to say we're going to group the number by 2's. So we have here square root of 3 squared times 2. And then applying the product law of radicals, we have 3 raised to 2 times square root of 2. So cancel this out, then the answer is 3 square root of 2. Okay, let's proceed with example number 3. So again, you can use other factor as long as the factor is equal to the radical. So 32, let's say I'm going to use here 16 times 2. Let's say this one is 4 times 4, then this one is 2 times 2, this one is 2 times 2. So let's check first our index. The index is 2, so we're going to group again these factors by 2. So let's say this one, that is simply 2 squared times this one, which is 2 squared, then times with this one, 2. Applying the product rule for radicals, we have square root of 2 squared multiplied to square root of 2 squared times square root of 2. So, applying our property, the nth root of a, which is this one, nth root of a raised to n is equal to a. So, this is simply 2 times, this one is cancelled out, which is equal to 2, square root of 2. Our answer now is 2 times 2, that is 4 square root of 2. Alright, let's continue with number 4 example. So, if we will apply, if we were going to factor this out, we have, let's say, 8 times 2. Then this is 2 times 4. This one is 2 times 2. Our index is 3, so we're going to group the factors by 3. So let's say this one, 1, 2, 3. So that is now cube root of 2 raised to 3 times 2. Applying, again, product rule for radicals, that is cube root of 2 cube times cube root of 2. So cancel this out. Then the answer is 2 cube root of 2. And finally, for our last example, let's say we will factor this. And this one is 8 multiplied to 3. So this is 4 times 2 and this is 2 times 2. So we will group it by 3. So we have 1, 2, 3. So rewrite it. That's now cube root of 2 cube multiplied to 3. And then apply the product rule for radicals. So that's cube root of 2 cube times cube root of 3. Cancel this out and what is left is 2 cube root of 3. Okay, so this is how we simplify radical expressions and we're going to apply this in our next lesson. Alright, let's try to analyze and solve this problem. Let's say we're going to simplify square root of x raised to 6 y cubed. So first step is we will group them into 2. The first group is called the perfect nth root. Okay, this one is the perfect nth root. And the next one is the group which is not a perfect nth root. How are we going to determine if that's a perfect and truth? First is we need to identify the index. So the lowest index in a radical sign is 2. So make sure that the power is divisible by 2. So meaning to say, if we're going to get x raised to 6, 6 here is divisible by 2, so that's why we will place x raised to 6 here. Next, we have y cubed. So if we know that cube is not divisible by 2, but then we can get y squared, and the remaining value of y will be placed here, so that this is now divisible by 2. So this is what we call perfect and truth. Next is we can simplify this. 6 divided by 2, the answer is x cubed. Then y squared divided by 2, that is simply y. And we will just affix the one which is not a perfect and truth, and the answer is x cubed y is square root of y. Okay, that's how you solve and simplify radical expression. Let's try to answer example number 2, letter B. We have cube root of negative 24x raised to 9. But before we solve for this, let's try to recall our past lesson. If you still remember, if the index is odd and the radicand is negative, our answer here is negative. Okay? So here the index is odd and the radicand is negative 24. So our answer here will be negative. So solve. So given cube root of negative 24 x raised to 9. So first is we will apply prime factorization here. This is negative 8 multiplied to 3. So when you multiply negative 8 times 3, the answer is negative 24. Then this one, this is 4 times negative 2. Okay, so 4 times negative 2 is negative 8. And if we will factor positive 4, we know that negative 2 times negative 2 will give us positive 4. So if we will group them, with perfect and truth and not perfect and truth, so our index is 3. So we're going to group the number by 3. So we have this one. So that is negative 2 cubed. Then notice that we have 3 here. So we will place it here. The one that is not a perfect and truth. Then we know that 9 is divisible by 3. So this one, 9 is divisible by 3. So we will place it here, x raised to 9. Again, this group is the perfect and truth. Okay? And this one is the one that's not a perfect and truth. So we simplify, cancel this out. What is left is negative 2. 9 divided by 3, we have x raised to 3. Then cube root of 3.
Thank you for watching, and please don't forget to like and subscribe to my YouTube channel. I hope you learned something new today. Goodbye.